Unit 5, Day 5. Hopefully the order I gave you earlier will help. It's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. I hope you saw how some of them reduced to over 2. And then 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. Both end at 2 pi. So if we have this point xy on the unit circle where the radius is 1, that means that we go over x and up y, and this is the right angle. So then sine is opposite over hypotenuse, which is just y. Cosine is just adjacent over hypotenuse, which is just x. And tangent is opposite over adjacent, which is just y over x. These are rearranged in a way that these are the reciprocals. So you flip over y over 1, you flip over x over 1, and you flip over y over x. Then I hope you see that because this is a right triangle, a squared plus b squared equals c squared, or a squared plus b squared equals c squared, and that's where this comes from. So we have this point here, negative 3/5, comma, negative 5/5, and to confirm it's on the unit circle, we have to show that the radius or the hypotenuse is 1, so we take x squared or a squared plus y squared or b squared, same thing. We get 9 over 25, 16 over 25, and sure enough, the hypotenuse is 1. So then the sine value is just the y value. The cosine value is just the x value. And the tangent is the y over the x. It's a complex fraction. This bar means division, so we can multiply by the reciprocal and reduce out the 5s and get 4/3 for the tangent. Once we have these, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent, the easy one, is the reciprocal of tangent. Now a little thinking here, if tangent is negative, well, that means that I have y over x, and one is positive and one is negative. And so that's going to be here. This is where x is negative and y is positive. Or here, that's where x is positive and y is negative. For this ratio to be negative, one's positive, one's negative. Cosine is greater than 0 or positive when x is positive. That's in the first and fourth quadrants. To have both of them be true, I have to be in the fourth quadrant. Sine is negative or less than 0 when y is negative in the third and fourth quadrants. Cosine is negative when x is negative. That's in the second and third quadrants. For both of them to be true, I have to be in the third quadrant. Now, there's this ditty that some teachers teach where all students take classes. So here all, that's where all functions, sine, cosine, and tangent, and their reciprocals are positive. Here sine is positive, and so is its reciprocal cosecant. Here tangent is positive, so is its reciprocal cotangent. And here cosine is positive, because x is positive, and so is its reciprocal secant. All students take classes. So then tangent is negative here and here. Cosine is positive here where they all are and where C is. So you can use this to do these problems. Quadrantal angles are angles that land on the x-axis. So that's this one, 90 or pi over 2. This one, 180 or pi. This one, 270 or 3 pi over 2. Or this one, 0 or 2 pi or 360. They land on the x or the y-axis. Okay? So for 90, we're talking about this point. The x is 0, the y is 1, and because it's the unit circle, the radius is always 1. And so sine is y over r, or the hypotenuse, and that's where we get 1. 3 pi over 2 is down here, though. And again, this is x, this is y, and the hypotenuse, or the r value is 1. And cosine is the x here, and so that's just 0. Let me jump to E, so you'll do these three on your own. (180) is here. Cotangent is x over y. The x here is -1. The y here is 0. Uh-oh, can't divide by 0. That's undefined. You again do these three using the x and the y where these angles land, and then the radius or the hypotenuse is 1. Try those. Here is where maybe you can use the idea of a reference angle. 135, well, that's short of 180 by 45 degrees. So this is our 45, 45, 90 right triangle. Here are the coordinates that we need to know in the second quadrant. And sine is the y value. We get root 2 over 2. 4 pi over 3. Well, this is 3 pi over 3, 1 pi. So one more pi over 3. So that's 60 degrees in the third quadrant. So to the left is -1/2. Down is -root 3 over 2. Cosine is the x value, -1 over 2. Pi over 3 is our 60-degree angle. So this is the short leg, that's the long leg. 1/2 root 3 over 2. Cotangent is x over y, multiplied by the reciprocal, and the 2's go away. I have 1 over root 3. I rationalize the denominator, and I get root 3 over 3. 225, well, that's 180 and 45 more. This is a 45, 45, 90 right triangle. You need to know these numbers. That's to the left, -root 2 over 2. Down, -root 2 over 2. Tangent is y over x, while anything over itself is 1. You go ahead and try E, F, G, H, and I. Again, trying to figure out what special triangle you're using, what quadrant you're in, and make sure you get the positive and negative SIGNs correct.